Off the coast of Mar del Plata, Argentina, at almost 4,000 meters depth on the floor of the South Atlantic, a remotely operated submarine vehicle descended into the total darkness of the most important submarine canyon of the region and found something no one expected to see with that magnitude or that richness. It was not a few scattered creatures adapted to the extreme conditions of the abyss. It was a complete ecosystem, vast, densely populated, and extraordinarily diverse, with coral reefs that no one had previously documented in that area, with jellyfish of gigantic proportions navigating in the darkness, with biological communities of a complexity that scientists from CONICET and the Schmidt Oceanographic Institute took time to fully process because what they saw on the screens did not correspond to any previous description of the South Atlantic seabed. Approximately 28 possible new species for science, found in an ecosystem that existed 4 kilometers below the surface without any human being ever having seen it. Leave your like, subscribe, and share. Let us begin. To understand why this discovery is so extraordinary, one must first understand what oceanographers and marine biologists thought existed in the depths of the Mar del Plata submarine canyon before the ROV of the vessel Falkor descended to explore it. The conventional view of the great ocean depths, especially in the South Atlantic, was that of an austere environment where life, though present, was relatively scarce and dominated by small, slow-metabolizing organisms that survived by feeding on the scarce organic remains falling from the upper ocean layers. Coral reefs, which in the popular imagination are associated with warm tropical waters full of sunlight, were considered impossible at those depths and at those temperatures. Complex biological communities, with multiple trophic levels and species diversity comparable to that of surface ecosystems, simply did not figure in the models that scientists had of the South Atlantic seabed at 4,000 meters depth. The Mar del Plata submarine canyon is one of those geological structures that exist at the ocean floor with a monumentality that the surface does not reflect at all. From the city of Mar del Plata, looking toward the marine horizon, there is nothing to indicate that a few hundred kilometers to the east and kilometers below the surface exists one of the most imposing topographical formations in the southwestern South Atlantic. The canyon extends from the Argentine continental shelf toward the depths of the Atlantic, descending steeply until reaching depths exceeding 4,000 meters in its most abyssal zones. Its walls are steep, its geology is complex, and the currents that flow through it create oceanographic conditions that, as the Falkor discovery demonstrated, are extraordinarily favorable for the development of life in concentrations that no one anticipated. The expedition was led by CONICET, the National Council of Scientific and Technical Research of Argentina, in collaboration with the Schmidt Oceanographic Institute, the organization founded by Erich Schmidt that has financed and equipped some of the most important ocean exploration expeditions of recent years. The vessel used was the Falkor, a top-level oceanographic research vessel equipped with the most advanced underwater exploration systems currently available for civilian science. The Falkor is not simply a boat with some underwater cameras, but a floating scientific platform specifically designed to support deep exploration operations, with the capacity to launch, operate, and recover remotely operated vehicles in complex ocean conditions and at depths of thousands of meters. Its arrival in the South Atlantic waters off Mar del Plata represented the meeting of the best available underwater exploration technology with one of the last great unexplored territories of the world ocean. The ROVs deployed from the Falkor are the instruments that made it possible to see what existed in the depths of the canyon without disturbing it beyond what is strictly necessary for scientific research. A remotely operated vehicle of this category is essentially a submersible mobile laboratory, equipped with high-definition cameras capable of capturing images with extraordinary clarity, even in the total darkness of ocean depths thanks to its high-power lighting systems, with manipulator arms that allow biological and geological samples to be collected without damaging the surrounding environment, and with a variety of scientific sensors that simultaneously record all relevant oceanographic variables of the environment they traverse. The combination of these capabilities allows scientists at the surface to observe in real time what the ROV finds in the depths, and to make immediate decisions about where to direct it and what samples to collect, making exploration a dynamic and interactive process rather than a simple blind data collection. When the Falkor's ROV began exploring the bottom of the Mar del Plata submarine canyon at almost 4,000 meters depth, the first thing that surprised the scientists was the density and extent of the cold water coral reefs they found. The coral Lophelia pertusa and other species of deep-water corals are known at some points in the North Atlantic and Mediterranean, but finding them in the South Atlantic at these depths and in these concentrations was not something that predictive models of coral distribution had anticipated. The reefs the ROV documented extended over considerable distances, forming complex three-dimensional structures that provided habitat for a diversity of associated organisms that exponentially multiplied the biological richness of the ecosystem. Leave your like, subscribe, and share. But the most extraordinary finding from the standpoint of marine biology was the reef of the coral Bathelia candida, a species of deep-water coral whose presence in the Mar del Plata Canyon was not known before this expedition. What the ROV documented was not simply the presence of this species in the area, but the largest Bathelia candida reef ever recorded by science anywhere in the world. The extent and density of the reef exceeded all the researchers' expectations and made this finding one of the most significant for the biology of deep-water corals in many years. Cold-water corals like Bathelia candida grow very slowly, accumulating their calcareous structures at a rate of millimeters per year, which means that a reef of the dimensions documented in the Mar del Plata Canyon took hundreds or even thousands of years to develop. Its existence there implies that the conditions at the bottom of the canyon have been favorable for coral growth over an extraordinarily long period of time. The giant ghost jellyfish that the ROV found in the depths of the canyon add another dimension to the extraordinary biodiversity of the ecosystem. Jellyfish of the genus Stygiomedusa, colloquially known as ghost jellyfish for their translucent appearance and intimidating dimensions, are deep-water creatures that have been sighted very few times in the history of underwater exploration. They are some of the largest known invertebrates in the deep ocean, with bells that can reach 1 meter in diameter and oral arms that extend several meters, and whose rarity of sightings has until now made the systematic study of their biology, behavior, and distribution difficult. Finding them in the Mar del Plata Canyon and documenting their presence with the high-definition cameras of the ROV represents a significant contribution to scientific knowledge of these extraordinary creatures. The cold seeps that the ROV documented at the canyon floor are another element that helps explain the extraordinary biological richness of the ecosystem. Cold seeps are areas of the seabed where fluids rich in methane, hydrogen sulfide, and other chemical compounds emerge from the subsoil through cracks in the oceanic crust. These compounds are toxic to most organisms but are used as an energy source by communities of chemosynthetic bacteria that, like the bacteria associated with hydrothermal vents, can produce organic matter without any dependence on sunlight. These chemosynthetic bacteria form the basis of complete ecosystems that depend entirely on the chemical energy of the subsoil rather than solar energy. And the biological communities associated with the cold seeps of the Mar del Plata Canyon include giant mussels, tube worms, crabs, and a variety of specialized invertebrates that scientists are only beginning to catalog. The approximately 28 possible new species identified during the expedition represent a first-magnitude finding for marine biology. Describing a new species for science is a rigorous process that requires detailed morphological analysis of collected specimens, comparison with all known species of the same taxonomic group, and in modern cases, genetic analysis that confirms the distinction of the new species at the molecular level. This process takes time, and the fact that Conisset and Schmidt Institute scientists identified 28 possible new species during the expedition means that the complete analysis of the collected samples will produce scientific publications for years, each one formally describing a creature that existed in the depths of the South Atlantic without science knowing it. The technology used to carry out this discovery deserves additional reflection because it perfectly illustrates how advances in submarine engineering are transforming our capacity to explore the last unknown territories of the planet. Modern ROVs like those operated by the Falkor represent decades of accumulated technological development in materials resistant to extreme pressure, maneuverable propulsion systems, high-resolution optics capable of functioning in extremely low-light conditions, and communication systems that allow the real-time transmission of images and data from thousands of meters depth to scientists at the surface. Without this technology, the ecosystem of the Mar del Plata Canyon would have continued to exist in scientific anonymity indefinitely, unknown to humanity, though completely indifferent to that ignorance. The decision to use ROVs to map and sample the ecosystem without altering the seabed beyond what is strictly necessary also reflects a philosophy of exploration that recognizes the fragility of these unique ecosystems. The deep-water corals that form the structure of the Mar del Plata Canyon ecosystem are extraordinarily vulnerable to physical disturbance. A net trawl or any other fishing or exploration technique that involves physical contact with the seabed could destroy in minutes structures that took centuries to form. The use of ROVs that observe, photograph, and collect punctual samples with their manipulator arms without disturbing the surrounding environment is the only ethically acceptable way to study these ecosystems, and the fact that both CONICET and the Schmidt Institute adopted this approach speaks to a commitment to preserving the object of study that is as important as the commitment to obtaining scientific knowledge. What the giant ecosystem of the Mar del Plata submarine canyon tells us ultimately is that the South Atlantic holds secrets of a magnitude that even the most experienced oceanographers had not completely anticipated. Less than 400 kilometers from one of the largest cities in Argentina, in waters that Mar del Plata fishermen regularly cross in their vessels, there exists a completely different world from the one we know at the surface. A world of total darkness where life has found ways to thrive with an exuberance and complexity that defy expectations and that fundamentally expand our understanding of what is possible in the planet's oceans. That world existed before the Falkor found it, and will continue to exist after scientists return to their laboratories to analyze the samples. But now we know, and knowing that it exists changes the way we understand the ocean that covers 70% of the surface of our planet. Leave your like, subscribe, and share. Until next time.